Hey guys, it's Bob, and I'm going to walk through the work I'm doing for the BLS project. I'm doing this in real time, so I apologize for any errors that come up while I'm working on this. What you can see right here is the website for the Bureau of Labor and Statistics. So if you go to Data Tools and then go to Top Picks, they have data sets for employment, for wages, for Consumer Price Index. The one I decided to go with is the average hourly earnings of all employees, seasonally adjusted, which you can see right here going back to 2006. You can download this data as an Excel file, which I did, and you can see it right here. The issue with this data is that it's not in a tabular format that's easy to work with, so we're going to have to do some Excel tricks to get that to work. So what we'll do is copy these, then we'll transpose it. Let's get rid of this formatting too. Sorry, this is probably pretty boring to walk through. And this is going to be our 2006 data. Copy this again. We'll use some formulas to add a year to this. All right, now we can copy this to get 2008, 2009, 10, 11, 12, 13, 14, and 15. So now what we're going to do is we're going to use a couple formulas to pull this data into a column format. So we're going to say we're going to use a formula called index, and this is our index of data that we want to look up. We'll go ahead and we'll lock these so that as we drag the formula down, those don't change. And then the row we want is going to correspond to this year here. So the way we're going to do that is we're going to use a formula called match. We're going to look up the year. We're going to look it up in these cells. Once again, we're going to lock them so we can drag the formula down. And then you type 0 to get the exact match. So what this does is it says the row number we need in this data is going to correspond to the year over here. And now for the column, we're going to do the same thing. So we're going to match the month in this case. We're going to match it from these cells right here. We'll use F4 to lock it, 0, and obviously January 2006 is 0, but if we type like an X, then it shows up there. So we know our formula is probably working. March 2006 we get 20.05. April 2006 we get 20.16. So it looks like our formula is working, and we're just going to drag that down. Let's do another quick check. April 2015 is 24.87, which we have right there. So it looks like what we set up is working. Let's just get rid of these. Oops, let's just keep those. Now we'll format these. All right, so we've got some data. Sorry, that took a little while. Now what we're going to do is the forecasting tool that the professor uploaded to Sakai. We're going to try two different tools to extrapolate the data that we got from the BLS. We'll use the exponential smoothing and we'll use Holt's method. So I'm going to select both these tabs. You can use Control, and then we're going to go to Move or Copy. I'm going to create a copy in my BLS data workbook. So we have our exponential smoothing and we have Holt's method. And you can tell in our data here we've got 110 data points. So we're going to change this. And now I'm going to take these and we're just going to drag it down until we get to 110. All right, so we have 115, which is good enough for us. Now we're going to copy our employment data. So Control C, go over to exponential smoothing. We're going to do a paste special as value. So if you go to paste, this one right here, we want just the values. And now we've got all of our data here. I'm just going to rename this to be BLS data. And using the formulas in here, we get an estimation for what the formula should predict based on the alpha we have right here. So the alpha is a parameter used in the exponential smoothing function, and the mean square error tells you what kind of deviation we have for the difference between our BLS data and our predicted values. It looks like something is going wrong here because we have 20.7 all the way down. So let's just fill this down one more time. All right, so something is going on with the formulas this guy set up. What an amateur. The issue here is this C5 to C22. So I'm going to change this. This part right here means not equal to a blank cell. So I'm going to change this cell range to instead correspond to just the cell right next to it. And now what it's going to do is it's going to take the cell above it plus the alpha times the difference between these two cells right here, C5 and D5. So the difference between the actual data and the forecasted data. And now if we fill this down, all right, we actually get some values out of this. The next thing we want to do is we want to find, and one more change we have to make is you can see that this formula isn't fully incorporating our actual data range. It only goes down to row 24, whereas our data stops in row 114. So we're going to change our 24 to be 114. Same thing here. We're just going to get rid of this if condition. I don't know why he set this up in here. And then one more thing we have to change is all right. Now that is going to actually calculate the mean square error for all this data. So we're good here. Now our next step is going to be to use solver to minimize the mean square error. So we go to data, solver. Our objective here is G6. So it looks like it's already set up. We want to minimize G6 by changing the variable in G4. The constraints here are that G4 has to be greater than 0, but less than 1. And we can hit solve. You can see here that in our chart, the forecasted values are now much closer to the actual values we have, which is good. So we're going to keep these values. We basically have 0 error, which makes sense because the more data points you have, the easier it is for the formula to get a smooth prediction. Now what we can do is we can click on this chart. We're going to edit this to be based off of, instead of 24, we're going to make it 114. My computer is on the fritz right now. Come on, series 2, we're also going to edit this. $114, except that we want to have a couple extra predictions here. So let's do 117. Good enough. All right, so you can see that the orange, our prediction drops off because it doesn't look like we have anything calculated. And the reason why is we don't have any actual data here. So the way to go about fixing that is, let's try setting this to, that's not going to work. For now, I'm just going to hard code that 24.87, 24.87. All right, that doesn't do anything for us. I'll have to look into this some more, but I just want to get this set up. So that's basically what we have to do for this project. I'm going to do Holt's method on my own. I won't bore everybody by walking through that. But just to summarize, we went to the BLS website. We got this data. We went to Excel. We converted our mess of a table up here into columns of data. We copied over the tools from the professor's resource folder, and we used exponential smoothing to get this set up, and then we used solver to minimize the mean squared error. So I'm going to go ahead and look at this some more and upload this. I'll put the file on Yammer, but let me know if this works or if you have any questions, and I'll talk to you guys soon.